Go ahead.
Oh, just like we're going to switch over so, you know, people can hear you.
I think. If I didn't screw up the audio, people can hear you.
The audio is the
Anyway,
hardest part of streams.
yeah, loopback. That's actually like OBS is cool. Loopback is really weird, but it works. We'll see if this. Yeah. All right. Yeah. It should be working. All right. All right. Since this will live for posterity, I should probably like, hey, what's up, everybody? We don't have a plan. My rough idea for this was was basically an NBC New Year's Eve event where people just sit around and watch the ball drop. But I pushed it out a little bit because I wanted to be available in case anything caught fire, which it looks like nothing did. I'm getting updates along with everybody else. And yeah, it looks like Anthony, who's running Zod, is okay. Oops, sorry. Well, that account kind of gets passed around for ops. But it looks like all our stars and galaxies, like the Tlon stars and galaxies, are up again. So that means that's very good. And so this breach is well underway. It'll be a little while before we start bringing other ships online, it sounds like. But anyway, Lane has offered to join me because he is this is his first breach, and which I think is sort of funny because I can't even remember how many I've seen. There was a period where we breached like every other day. But anyway, I figured Lane would get good.
First and hopefully last.
Oh yeah, that's true. People keep kind of like hedging on this. It's true that it could be. This is by far the most painless breach, right? Because the thing is that breaches used to always mean you actually like lose everything in between because you had to do a full reset. So this breach includes data migration. It really actually should be like not, it's sort of annoying to turn everything off, turn it on again. But anyway, my thought was that Lane would be a good person to give background on like what the hell this even is, because I'm not sure everybody knows exactly why we do this and why, like what it means to reset the Urbit network. And then we can maybe talk about what's actually going in. I'm not even sure you know everything that's going in and why we had to do this in the first place. And then I figured I'd just start texting people and seeing who's available and who wants to join this call and chat about this until we get run out of things to talk about, or maybe the network comes back online or whatever. But yeah, do you understand? So do you understand what a breach is and why we breach? Like that's kind of maybe.
Yeah. So I'm maybe the right person to be on the other side of this conversation because I know very little about Urbit, and I'm like totally comfortable admitting my ignorance, but hopefully know enough about the big picture to be able to at least ask and structure intelligent questions and understand the answers. So I know that there are two types of breaches in the Urbit world. There's a personal breach and a network breach. I know that a personal breach is something that you have to do once in a while, hopefully never, but some people have to if their ship gets screwed up, like mine has become screwed up.
Yeah, unfortunately.
Yeah, and a network breach is a completely different beast, and we should also remind people that they don't need to do any sort of personal breach today or as part of this. This is a network breach.
Yeah.
And I guess I understand that we have to do a network breach once in a while when there's an update that can't be pushed out over the air. So it might be worth talking a little bit about the difference and how updates typically happen. So that's sort of the level of my understanding right now.
Yeah, that's, I think, actually probably like the common level of understanding. So let's see if we can kind of upgrade it. You can basically, I'll try and explain this concretely. You'll see the limits of well, I understand this technically like pretty well, but Philip can show up later and go even deeper potentially. But maybe we can distill it down. So there was a long time where the idea of a personal breach didn't exist because, a lot of this basically centers around, I think of it as basically being about exactly once messaging. So in order for, you have all these, well, let's back up a little bit. So Urbit is a piece of software that runs, it's like an interpreter that runs, this little sort of like microkernel or little operating system. We call it an operating system because, the fact people get picky about like operating systems have to run on metal, whatever. It's basically an operating system, but it's virtualized, of course. So it runs. There's an interpreter that runs this, that interprets NOC, basically the virtual machine of Urbit or of Arbo itself, which is the kernel. That runs its own network and can update itself over that network. I guess to maybe put it in clearer technical terms, like think of the interpreter as basically like libuv plus a NOC interpreter, right? So it has this formalized way that it talks to Unix, and like it only knows about certain event channels that can come in. So that thing doesn't know how to update itself. right? You can think of
And
the
just to be clear,
interpreter. Yeah.
Arvo is written mostly in C, so it's not sort of self-hosting the way that the rest of the Urbit system is, right?
Sorry. So um, Arvo is written in Hoon. The interpreter is written in C. And so
The interpreter's
Arvo,
written in C. Okay,
everything in Arvo can update itself, including the language. So Arvo is written in
got it.
Hoon. Hoon comes as like part of the OS. Those are all of that is stuff that we can update over the wire. There's all kinds of interesting problems about updating your own programming language, but the whole idea is that that's self-hosting, right? Like you read the running source, and you can inspect the file system, look at it, and that's actually what's going on there. So we, at the Unix level, we're basically running, we're speaking UDP through the interpreter. So you can think of the interpreter as being something that changes a lot less than this little OS, right?
Does
Like
the
it
interpreter have a
just,
name?
you can call it var, yeah.
Var is the interpreter. Okay, got it. So that's the
Yeah.
layer that's the lowest layer. That's the thing that's written in C. That's what serves as the glue between the Urbit world and the underlying operating system.
Yes. Yeah. Right. Yeah. Actually, it is probably helpful. Even in talking about this, I'm like, this is not a great explanation. It's got probably, so we can try and compress it. So you have var that basically is just like this event system, like handles moving events from Unix into Urbit and back, right? And so it interprets knock and it handles I/O. And then you have the actual running Urbit source, which is effectively just this big number. That's kind of the whole idea, right? Urbit is a giant number. It's a single function. When you then var says, hey, here's this new event that you know how to, I'm going to give you a new number to basically, use your function to compute a new state number or whatever, right? Like I'm going to send you an event number, and then you're going to compute a new state number. So that state number contains your operating system. We know how to turn that into text that you can inspect and so on. Anyway, so right, the interpreter knows how to update that effectively, right? Or it has its own logic for updating that, like because events come in over the network, we figure out how to compute its new state. And we're doing that all the time. Like every time you get a chat message or a new publish update, a new link, whatever, those are effectively the same type of thing as getting an operating system update. So the problem, of course, then is, well, what happens when we want to update the interpreter itself? Because we want to, I don't know, there could be security concerns about how you break out of the sandbox, or there could be I/O changes that we want to be able to handle I/O differently, or whatever it might be. So the reason that we would often breach is because you have to update that interpreter. You have to force everybody to update the interpreter. There's some breaking change in the interpreter that we can't ship over the air. I feel like there have historically been other reasons that we ended up breaching because, yeah, so historically, like a long time ago, what we used to do sometimes is if we had a big kernel update, in order to actually successfully, let's say your ship is offline, we ship a huge kernel update, then your ship comes online, starts talking to people. Obviously, you can account for this by like figuring out all your schema migration and data how to account for like, oh, there's someone who's out of date, make sure they upgrade before they talk to me and stuff like that. And now we're a lot better about that. But it used to be sometimes we'd be like, fuck it, let's just breach. So that's why, like Philip and I have been through like hundreds of these things.
That should be a meme and probably also a T-shirt. Fuck it, let's breach.
Yeah, I mean, it's something that we used to do. It's one of these things that like we originally was like, do not ever, the whole idea was like never breach. Like it's supposed to be continuous forever. And so we tried really hard not to, and then it's like we're 5 people, fuck it, like you just can't. It would be so much work. You're like, oh, do we want to do a month of work so we don't have to breach? Or there's like, who knows? There's probably 500 people on the network. Like, let's just reset it. So anyway, as the network has grown, you obviously want to do that less because it's like this whole. For anyone who's self-hosting, you have to actually take action. So I guess there's the problem of I have to update the interpreter. And the other thing that often causes breaches is that Urbit's networking is stateful. So like if you and I are talking, the way that we guarantee exactly once delivery is this really simple thing, which is we just have like a sequence number for every packet. So obviously packets get dropped. We can't guarantee that that packet got there. But if I am trying to send you message 6 and you're like, hey man, I don't know, I haven't heard 5 yet, then the internal logic of our networking basically then says, hey man, send me 5. And so I'll send 5. So at the application layer for the programmer, it's really cool because you can just assume that everything, gets delivered, and we handle all of that. At the networking layer. It could be that I'm like sort of fudging this technically, although I'm pretty sure that's correct. But anyway, that's one of the reasons that the personal breach was always like, it used to be before you could do a personal breach, which now there's basically this exception you can throw where you're like, hey, actually I forgot everything, forget all of our subscription numbers, can we start over here? And that's like what a personal breach is. It used to be you couldn't do that. So if your ship went down during a continuity era of the network, you had to basically start another ship or something until we breached the whole network. So now you can just reset your ship and restart your subscriptions, and it's like a lot more permissive in that way. But another thing that like doing a whole network breach does is that it basically resets all of that subscription logic. And actually, one of the things that might be worth asking Philip for something is, now we have data migration. So we have a way that we basically say, hey, take all of your user space data and dump it to a giant number, basically, and then restart your ship and import that data. But I'm pretty sure that it's not going to keep your like subscription numbers or like your networking state, because I don't know how you would keep that. Anyway, that's a little bit meandering. Does that actually make sense? I think that makes sense.
Yeah. So no, it all makes sense. I think there's a lot of questions I would love to follow up with, but the most pressing one is kind of like looking at this from a UX perspective. I'm sure. So I'm wondering this myself. I'm sure many other people are wondering this right now. Like, let's say I use the flag day tool, which is something we should talk about, to dump my data, like you said a moment ago, my user space data, and then re-import it again after the breach. What is the UX going to look like reconnecting to Urbit after the breach? Like you said, if the networking state is lost, are all my like DM channels going to be open? Am I still going to be in my channels? Do we know what that's going to look like?
Yeah. So I forgot that there's a chat and people can ask questions and comment. Just so real quick, Philip actually is, good point. One of the reasons we used to breach is because we had horrible memory leaks. And so you'd have, not only do we not have the ability for things to personally breach, but then you'd have, say, a galaxy that did get a lot of traffic. Especially we'd release something. All these people are like, oh, Earth's really cool. They'd come back on the network and then they'd, a ship would basically explode because its event log would overrun, and then you'd have to breach the whole network. So that is true. That was a common problem. Anyway, so how does this work this time around? Yeah, the idea is, it's funny, I haven't used it, although I do think someone did do this for me. Thanks, Isaac. The idea with flag day is effectively that I'm not sure, what the like command line arguments are or whatever, but basically, Charlie's close. My understanding is, and I don't understand deeply enough to give you a more technical answer, but effectively, okay, so from a user level, it should just be like, I run flagday.sh, pass it something like the peer, like turn your ship off, you run this command, and it effectively dumps all your state and then starts the ship again. Philip is basically, we should maybe just like, we could come back to this when I can get Philip to join, which you could potentially do shortly. But anyway, the idea is, you run one command, start your ship again, and everything should be back to normal. And I guess it sounds like, it may re-invite you in the case of private groups. I was actually always really confused by like, there's some weird logic there, right? So it's like if someone's hosting a group and then the group goes down but the subscribers come back up before the group exists. Anyway, there's some black magic there that I don't quite understand, which I imagine probably does have to do with how subscriptions get reinitiated or invites get like resent, if that makes sense.
So it's good. It's a good thing that there are really brilliant engineers working on this, because this sounds like a very complex engineering challenge.
Well, I think Urbit in general makes it's relatively complex. Like the system itself makes it somewhat easier, right? Because it's like, as I understood it, flag day does just basically dump a noun, right? It just dumps out this giant number, and then it's effectively like a, you can think of it like you're just dumping your database state and then re-importing it. The hard part is how you go reinitialize all those subscriptions, I think. But maybe this is like, we should just bookmark this and ask someone how. I don't want to, everyone who works here is brilliant, but the whole idea of Urbit is sort of like, make the foundation as simple as possible so this stuff like this becomes easier, Anyway, so this is unusual. This is something we've been trying to do actually for quite a while. So of all the things, there are kind of three major things that went in, that are going in, like the reason that we're doing this. The main reason we're doing this is version negotiation, which we talk about. The data migration thing is something we've wanted for probably 9 months and talked about for a long time, because there are still occasionally cases where your ship can be corrupted like yours, right? And you want to be able to take, for the most part, these are memory leaks or they're edge cases. We've gotten them down significantly, right? But they still exist. So in the case that you have a ship that's corrupted, you want to be able to basically like rip the data out of it. It's almost like pull the hard drive out and put it back into a new machine. So data migration is big. Yeah, I think that's sort of, that's how I've been thinking about it for a while. It sort of violates, I feel like I wonder, try and find like find people who worked on Urbit in like 2013, 2014, because it's, it violates some of the ethos of like early Urbit, which was sort of like never, it was just like you should never ever have to reset it. But I think that ultimately is not realistic. Or it's like you'll let people reset it for a while and then eventually not reset it. Anyway, so data migration is big, version negotiation, and then we made a bunch of AIMS protocol updates that we probably could have OTA'd, but we just did a security audit, so we audited AIMS, which is awesome. There are still things that can be better about AIMS, but in general, the basic architecture is kind of like rubber stamped, at least. I mean, I don't know. I feel like auditing firms probably don't want you to say that. I don't know. An auditor looked at it, they think it's reasonably good. There are things that we still want to improve about it. So those improvements are going in too. There were like a few small things that they wanted us to fix that we fixed. And that's easier, as you can imagine, like upgrading the entire, that's like you could upgrade the network protocol. It can be a little bit challenging. So yeah, anyway, data migration is kind of part of it. I'm happy to have data migration because it does mean that although you never want people to hit these cases, but like in your case, even if we weren't breaching the network, right, you could just run effectively, like be able to run something like Flag Day and just keep going. And so for us with hosting, this is especially important with hosting. Like this is the thing that actually has made me the most nervous. We're hosting a bunch of people, and luckily none of their ships have exploded or nothing bad has happened. But we were sort of racing to make sure that we had a tool like this in the case that something does go wrong for a hosted customer, right? Like you want to make sure that they should basically notice nothing. I mean, you'd say like, oh, we have to do some maintenance or whatever, and you just kill the ship and restart it with new data. But yeah, I don't know if you want to walk through. Does that you've got to reflect back to me whether maybe you should try and explain now. Do you feel like you can explain like why we breach or why we're breaching in this case?
Yeah, I mean, I think so. I think your explanation makes sense. It sounds to me, if I'm understanding correctly, like for example, you talked about upgrading AIMS, and that could maybe have been done without a network breach, but it's much easier to do with a network breach. But it also sounds like the version negotiation specifically is something that could not have been done without a breach. Am I understanding that part correctly?
Yeah, that's the main thing that like forced the breach. So again, I guess it's like at a high level, when you have like breaking changes to the interpreter that you have to ship without version negotiation, without any way for the running OS to say, hey, I need you to upgrade your interpreter, we don't know, right? Like if there's a let's say we ship a new version of the OS that wants new IO channels of some kind. We don't know. We don't know how. We can't force you to do that without version negotiation. So version negotiation is basically, I think of it almost like, it's gotten a lot better, but it used to be like your browser would just say, you need to upgrade. I mean, some apps do.
Eventually, right.
Yeah, I mean, eventually it should just be like, I'm trying to think of some of them do it. I'm not sure we know exactly how interactive it should be, but the idea, right, is that somehow the system itself should be able to download it on its own. The first step is it just says to you, hey, you got to go install a new binary.
So this is something we could talk about. This is the part of the breach that I find the most interesting. So as you know, I come from kind of a blockchain world, and our how do I put it? Like it's not exactly the same thing, but like the conceptual framework through which I think about a breach is what we call a hard fork or a network upgrade hard fork in the case of blockchain like Bitcoin or Ethereum. As I said, they're not exactly the same thing, but when you have a network hard fork upgrade in a blockchain world, there's a lot of interesting governance implications for the system, right? So like there's this very interesting tension as someone who sort of designs and builds blockchain software, right? On the one hand, you want to make things as easy as possible for the user, and you want them to be able to kind of turn on some auto update flag and have them not need to think about it and the software just update itself. On the other hand, to do that, and this is nuanced but very important, to do that, to allow users to turn on an auto update flag is to take agency away from node operators. And in the case of blockchain, that's a very big deal because the role of the node operator, they have a very important role in governance. It's sort of like a veto role. This whole governance kind of process plays out, and core developers make decisions and roll out software. And then ultimately, at the very end of that pipeline, you have node operators who choose to upgrade or not to upgrade, and sort of
Yep.
to ratify the protocol changes. And if you make auto updating too easy, you take that away from them. So I know, again, it's not exactly the same in Urbit, but I wonder if that tension is present here as well, or not at all.
I mean, a high level is not that different. Let's see. I think that, so in a mature Urbit world where you have like a bunch of different, infrastructure nodes, stars and galaxies online, the way I imagine it is that most of the differentiation in terms of like what they run and what software they distribute is at the, almost like in user space, right? Like certain stars may distribute a particular, app of some kind or whatever, or protocol, whatever it might be. Like they have a modification to the running operating system that's like unique to that star or that galaxy or whatever. Or it could be even that portions of the network, it's like the difference between, I don't know, like Slackware and FreeBSD or whatever.
That's a good way of putting it. So actually, this Linux analogy works really well for me because they share a kernel. The kernel is the same, but the package management and the subset of packages they choose to roll out is what differentiates the different Linux distributions.
Yeah, so to be clear, we're not quite there yet. Like this is like probably the next most important area of like kernel and like OS work has to do with like how we actually solve software distribution so that you can have concurrent distributions. And it's likely that like certain parts of the network, like if a certain part of the network can't really run like a different networking protocol, like that's going to be very difficult to figure out. How do we even send packets back and forth? But a different part of the network could run maybe like some parallel application model or something. But that maybe someone could definitely run just like a different, like a spreadsheet Gall app or whatever, that stores tabular data and shares around, something like that. So you'd imagine that the kernel itself, so the vanes, so Arvo is this set of what we call vanes that are like kernel modules, and then Arvo itself, which is basically event dispatch between those modules. Ideally, that is the thing that the whole network agrees on. And the idea is that sort of like stars and galaxies perform exactly the same, well, very similar governance to what you're talking about. Yeah, people are asking questions or making contributions.
Yeah, I'm keeping an eye on the chat here as well.
Oh yeah, Joe's a good point. I mean, Joe's the person who's worked most on version negotiation. That's a good point. So yeah, anyway, I guess the chat is concurrent with, people can see it alongside us. And this is also one of the weirdest parts about streaming is that these guys the chat always comes in, 30 seconds after you said something. Let's see. Anyway, so you'd imagine that the idea is to keep the kernel consistent because that certainly like makes Urbit work the best, and you want node operators to perform a governing role there basically. And ideally, the way I've always thought about it is like there's always, and this is pretty similar. Ideally, there's core developers sort of like develop the kernel and effectively propose patches to it that then node operators accept and ship to the network.
Right.
The default situation is that, galaxies are totally they don't sync to one another. Each one has to put in its own kernel upgrades, and each of their sponsees or each of the stars that are sponsored by whatever galaxy gets those updates automatically. But you can.
The galaxy is the only layer that does not receive automatic updates. The galaxy is responsible for doing the updates, and then it kind of filters down through the stars and the planets, right?
That's the idea. They could easily sync to one another. I actually wouldn't be surprised if we take some of our galaxies and like sync them to one, so that you only have to like patch one and then it all goes out. Like it's like out of the box, the thing just looks for its sponsor, and that's where you get your updates. You can tell it to go get OTAs from somewhere else, right?
Okay.
But anyway, there's no scheme for this when it comes to the interpreter, was all I was going to say. So it's like the governance isn't that different from blockchain governance in some ways. And yeah, we have kind of like automatic upgrades turned on by default because you could have these kind of like network segmentations. That would be like probably not desirable by anybody. Still something, yeah, sure. You could have these, I don't even know what you would call it, right? It's not a fork really, you have like an internal schism or something like that. Do you know what I'm saying? Where like part of the network would like subdivide. Yeah, I mean, certainly it's like SegWit, right? It's like imagine that like that in the block size debate, it's like Bitcoin actually just was like, I mean, I guess this is in some ways what happened with some of the forks or whatever, but it would be that kind of thing, except you'd actually take the existing azimuth address space and just say, okay, some of these people run a different protocol.
Right. So for example, Charlie here, I'm assuming Charlie's a Galaxy operator. He says he just syncs his Galaxy to Zod, so that's good to know.
Yeah. Yeah, that makes sense.
Um, yeah, I think this is a really interesting question. This is something I would love to ask Joe or Phil or any of the other engineers later. Like, what would happen if hypothetically, let's say an entire galaxy, whether intentionally or unintentionally, like chose or just didn't participate in an upgrade? Would they
Yeah.
be, if fork is not the right word, what would the right word be? Would they be cut off from the rest of the network? I guess is what we're asking.
Well, all right, let's see if we can, that could be like a good segue. Let me try texting someone. Or I'll try texting Philip. These guys are in the chat. They could still be, it's
Yeah,
probably easy to be in a YouTube chat and be doing ops, so I don't really know
right.
how. Oh, interesting. Oh, he can also, oh, okay. So yeah, it sounds like they, I guess it's a good moment maybe to like take a break, because I should probably also, okay, cool. So it sounds like everything came back, and it looks like instructions for getting back on the network are up at urbit.org/breach.
Awesome.
And I don't know if these guys are still doing some ops stuff.
I see a Zod is okay message, so that's a good sign.
Yeah, that's always reassuring. I also, I guess, well, I was not going to do it, so now I can release this to someone else. But I once checked if you could get the vanity plate Zod is okay, at least in California, and you can. So someone should really do that. Uh, let's see here.
I would love to hear the story of Zod. I don't know if there is any story of Zod.
I
Is
think it's a. Actually, don't really know. I mean, the phonemes existed by the time I started working on Urbit in like 2013, 2014. We changed them only to remove some really offensive permutations that were accidental, of
I could
course.
I could imagine those. Yeah.
It was really funny. It was like one of those funny things where like someone actually starts mining. You know, it's not that hard to write an
Right.
algorithm. It just looks through the phonemic
Right.
set and is like, what are these? What are the English words? And then I think there were some that were really unclear how to pronounce. I always find like people
Right.
like WYT, for example. It's like, is it
Yeah.
wheat or white? You know?
The Ys are problematic for native English speakers, definitely.
Yeah. Uh, but Zod, yeah, I don't know. I think that,
So my understanding is that every Urbit ID translates basically just to a number, right? Because there's some total
yeah,
number of like entities in the Urbit network, including galaxies and stars and planets. So is Zod like zero? Is that
yeah,
kind of how
Zod is
this
zero.
works?
Yeah, yeah, yeah. So I guess maybe that's like, I mean, I feel like there are all kinds of like, okay, Phil says he's ready in about 10 minutes or so. So like,
We
calm
just have
down.
to shoot the shit for 10 more minutes and not make
That should be
fools of
too
ourselves.
bad. I mean, I'll happily make a fool of myself if I can find the opportunity. Yeah,
Happy
Zod
to
is
do the same.
zero. Um, I don't know if there are any like, I feel like there's lots of like kind of funny, you know, intentional double meanings. This is like General Zod, right? Which I've never seen. Have you seen whatever that? It's like a Superman movie.
This is a non-Urbit thing. This is like a, oh, I see. Okay, General Zod. Yeah, okay.
Yeah.
And this is from 1961, so this is definitely pre-Urbit. Yeah.
Yes. Yeah. I don't get it really, or like I haven't. I'm not familiar enough with the. Um,
Um,
Actually, although there
Charlie
was
says
a. Oh yeah, go ahead.
galaxies used to have nicknames too. Zod was Tianming, which sounds Chinese to me.
Yeah, that's true. There used to be, there were like cities though, I think. Because the idea was that it's like and urban. There were all these kind of double
Right.
like jokes about like, it's like writing software for Urbit was like, because like all the jokes about it being like street functional programming or something. Do you know what I mean? So it's like Urbit, like it's like urban
Right.
programming. Um,
Right.
uh, I mean,
I
I
like
think
this. Zod is
that's
going to turn into a Landian rogue AI. That's great.
probably true. Yeah. Uh, Oh, I guess Tianming was probably is like the right. Oh, it's like the Confucian. mandate of heaven thing.
Could be, yeah. So Tian means heaven in Chinese. I could see that.
Yeah, I'm not even familiar with the. There are all kinds of like. I mean, I think that the it's like
Charlemagne.
there are
Oh, I get it. They were named after like emperors or something. This would totally make sense.
it would make sense. There was, but there were a bunch of other, like, the thing is that the galaxy star planet thing went through all these other iterations, right? Because at some point
Right. They were
before I was even there,
ships.
well, no, they were like dukes and earls, which is like
Right.
embarrassingly hilarious, you know.
Yeah.
And
For a lot of
then
reasons.
yeah, uh, wait, then they were ships, yeah. Then they were like cruisers, carriers, destroyers, or something like that.
Right.
I don't know
Like
if there was
classes
an
of ships or battleships or something.
yeah. Uh, and then we moved to the. I think I couldn't handle the ships. I was like, this is ridiculous. But to be honest, I might have been the person who was also like, the Dukes were too much. So this is like too much LARPing for me.
This is the LARPing is a great term for it. No, this is the Urbit lore that I don't know. Like I have this like event series that we're investing time in, and like this is precisely the type of not the technical knowledge, but like the kind of
Oh,
community
like
social knowledge
cultural,
that like
yeah,
I want to the cultural knowledge that I'm hoping to kind of capture in that series. This is actually really helpful.
yeah. I mean, there's yeah. Happy to. It was like I'm trying to think of. I mean, the state of the whole Urbit as a like part of the attraction of Urbit. I was kind of talking when I talked to Joshin last week. It was funny to talk to him. I mean, he's someone who I've stayed friends with, so we talk casually a lot, but we don't talk a lot about 2013, 2014 Urbit. And it's true that like Urbit was had this part of the attraction of the code base even at that time is that it had this kind of extremely sort of whimsical poetic like attempted poetics, some of which were more
Yeah.
successful than others, but it's like nice to see. I think that was kind of like um, uh, it actually like one of the things that's kind of funny about that to me or like is important or I don't know like was important to was hard to communicate publicly, I think, is that there were all these things about it that were very deeply unfinished and just kind of either dumb or broken or bad. And then, like, if
Right.
you actually changed them and upgraded them, they could be good. But some of the poetics actually, like, I always thought, like, yeah, the urban, urbit, like the digital city, the ancient city kind of thing, like a lot of that stuff actually worked. And then, like some of the other, I mean, yeah, some of the four-letter words I could do without. It's like a little extreme. But it can be really off-putting at first. If you're like, oh, this is set in stone, this is the way it's supposed to be, it's like, yeah, it seems completely insane. But if you think of it more like a work in progress, then maybe it's they're just pieces that need to be improved. Um, let's see. It's really hard to juggle like doing two things at once. I hope I'm not letting anyone down on. I still help
Not
people.
missing some critical message. Someone needs your help with the breach or something. I'm sure it's in good hands.
I think it seems fine. Yeah, surprisingly. Um, Yeah, it's funny. I never did a lot of breach. I mean, I guess there were times where I would breach individual ships. I mean, for a long time, I guess just to like unearth more of the cultural lore, it's probably like, let's see, I'm trying to think of like how we actually would run the network. I'm pretty sure we almost always ran it mostly on GCP because we had
I was
some
going to ask if
weird.
there was. Uh, I met someone recently who was one of the first, if not the very first, sort of large scale miner in the Ethereum network. So going back now to like 2014, 2015.
Yeah.
And I learned that around the time of the Ethereum genesis, and I don't know, for some point of time, some number of months after that, like some double digit percentage, maybe as much as like 30-40% of the hash power of the Ethereum network was like run out of this individual's closet or something in
Right.
some random developing country. So I'm wondering if there was ever a moment when Zod or maybe all of the galaxies were running on some old piece of hardware under someone's desk in some office or something. That'd be a great piece of like lore.
We never ran. We always wanted to run. I mean, cloud services are so insanely overpriced, and we don't
Right.
run, that close to the metal, but like we need very little. Like it's just a single process. And so we've always talked to people about co-location and like trying to do things more directly. But then I think we just totally, it's like embarrassingly simple. We got like through an investor or something, we got a huge, one of those like startup, like
Yeah,
free,
I've had those before. They're
yeah.
game changing.
Well, it's stupid because it's like we got locked. I mean, it did exactly what it did. It was a big favor to
What it's
Google,
intended
right?
to
Because
do, exactly.
they
And
gave us like,
like,
150 grand of GCP, but of
right,
course it's only for like a year and a half or something. And so we probably
right, and then
used,
it runs out.
yeah, we used, I don't know, uh, 10 grand of it maybe, and then it runs out and now we
Oh
just pay
wow.
them. Uh,
Yeah, so you were like barely using any. You should have been doing Bitcoin mining with the rest of it or something.
That would have been yeah, that would have been amazing. Yeah, no, because it was so early, we weren't using it very much. So we were only running like
Right,
a couple ships. And then I think, yeah, for a long time, it was always just like, there's just like one giant instance with like a bunch of ships running on individual
right.
screens. Yeah, it has been like now with hosting uh, our automation tooling is a lot better. Although we don't use a lot of automation. Actually, that's not true. We have separate automation tooling that runs our infrastructure. That's not, and then all of our hosting stuff is all in Kubernetes, whereas the infrastructure stuff is like bespoke. So relatively simple. Philip could probably give some background on that. The tool is called Janeway. That's all I know, and I know a little bit about how you control it, but I don't ever do that anymore. It used to
Cool.
be just like you SSH into something and run commands directly. Um,
That's very like 2004. So you know what I'm saying? Like, I mean,
yeah,
I'm being tongue in cheek, but we have all these really powerful orchestration tools now. We have the Kubernetes and the
yeah.
Ansibles and things, and like it's amazing what they can do.
Right. Well, that's I think because we were always on the fence about like, do we want to fully commit to using
Right,
like cloud services, basically, right? So it's like, do we want to
right.
commit to orchestration tooling, or do we want to actually figure out how to do this ourselves? And honestly, it's pretty obvious that eventually we do need to figure out how to do this ourselves, probably because it'll be a hell of a lot cheaper. Um, it's
When
a
you say do
trade-off.
this yourselves, do you mean metal? You mean like an actual like data center somewhere, or
Well, probably colo to begin with. It
yeah,
just
yeah, yeah,
like,
yeah.
at some point that cost makes sense. I mean, yeah, the markups on cloud services are just completely insane. It's like between 10 and 100x what you would pay for just running the thing yourself. But of course, there is a lot of convenience because it's a lot easier to plug your
Right.
automation tooling in. So, I mean, we're not that big. But I can like see those, you can see that trade-off pretty clearly. I
So
mean,
yeah, this is interesting business school math. Like I'm just back of the envelope wondering how many planets or stars Tlon would have to be hosting before the economics you'd hit an inflection point. It would make more sense for you guys
yeah.
to be running your own.
Well, I mean, the economics are pretty simple, right? Because it's basically like how many people does it take? It's just a
Right,
question of our overhead is partially on the
right,
side of running the actual nodes, but it's mostly on the side of like who can actually operate it. So I
totally.
think it would vastly exceed our capabilities in terms of personnel to run however many hundreds of shifts we run, you know.
Right.
But it would not be worth it but building all that tooling to do it ourselves would be that'd be wild. Um, I don't know. This is an ongoing debate, but currently the person who does our automation seems to like be pretty reasonably happy with GCP, and he does a very good job.
Cool.
So, um, uh, now I'm just reading the chat
Got you up on
backlog.
the chat. Yeah, there's some fun. I like the pep in the short. That's kind of a funny name.
Uh, yeah, it's funny that they don't. I mean, the other thing this reminds me of is just the fact that like one of the things, it's kind of a weird thread, but one of the things that came up in the Ames audit. So we'll publish a postmortem we'll publish the audit and the postmortem, and there's sort of like three sort of areas we want to work on. One of them is forward secrecy. So it's like the protocol itself is secure, but we don't, and you can cycle your keys on chain. We don't have an automatic
Hmm.
ratchet, which we would like to have. Um, the other one is DDoS protection,
Hmm.
and this kind of overlaps with then also like basically like boundaries around like sandboxing and like remote code execution and stuff like that. So like if I send you a
Hmm.
packet, but I'm authenticated, like how can you make sure that I can't just like send data directly to different parts of your OS? There are some security, I can't just read any data on your orbit, right? But anyway, the DDoS stuff is interesting because it kind of gets immediately at reputation, right? It's like, okay, well,
Totally.
if I can authenticate, there's problems of like me being able to DDoS you by or just not DDoS, just DOS you, right? Just by sending you a ton of packets and forcing you to try to decrypt them. But then once you've decrypted them, let's say that I'm authenticated and you just like, you actually authenticate me, but I'm just spamming you with packets. How do you go and tell the rest of the network, hey, this guy just keeps, the idea is that, well, you want to be able to use that reputation somehow. The network is still friendly enough that we don't need that. But anyway, I was just thinking of like galaxies don't even have the ability to identify even as Pep in the Short. But someday they need to be like Pep in the Short, the the abuser or whatever, the network abuser. We'll get there.
So everything you just said, the past like 2 minutes, are all, we run into the exact same issues in the blockchain world. The issues of P2P and spamming and DDoS and reputation and what do you do with peers who are sending you garbage and authenticated. Yeah. Anyway.
Yeah.
So this is very familiar.
So wait, I've actually always been worried, or like not worried, but definitely wondered about this. So if I have two ETH nodes that are like, how do they authenticate each other? Has always been the question. I actually never understood this, right? So yeah.
Yeah, I'm not super familiar with that layer of the Ethereum node, so I'm not precisely sure of the answer. I can tell you in the case of Bitcoin, there is simply no authentication. Like a node will just basically talk to anybody. Yeah, there's no like
how do they discover
exchange. There's no encryption. Well, discovery is an entirely separate question, right? I mean,
okay.
And this is very different between Bitcoin and Ethereum. Ethereum uses a DHT, like a distributed hash table. Yeah. Bitcoin does not. Again, this is not sort of the piece of the protocols that I've worked with the most closely.
Sorry.
But I thought that was interesting as I was sort of like studying this, the fact that like, I mean, Bitcoin is the most obvious example. There is no authentication, no encryption. And maybe this is something where Urbit has an edge because of AIMS, like every packet, like you know where it came from for sure.
Yeah, I mean, you still have, so the interesting part.
And
go ahead.
The idea, my limited understanding of like why this is not felt to be necessary in Bitcoin is that like ultimately all the data is going to end up on a public blockchain anyway, so there's no point in encrypting it in transit between two nodes.
Yeah, right. That's kind of what I kind of assumed, which actually means that they have a similar sort of DOS surface area to us, which is that you can send us a bunch of packets, and if we can't decrypt them, and like if we can't authenticate them, then we don't do anything with them. But you can still overwhelm us with packets that,
sure.
Forcing us to
yeah, but so this is something that should be dealt with at the P2P layer, and hopefully the node software would be smart enough to drop a peer and ban a peer that's sending it junk. And this goes back to reputations and identity. If you can't, I mean, one way you can sort of ban a peer is by banning their IP address or their subnet range or something, but maybe they'll just attack you from a different subnet if it's a DDoS attack. This is a tricky problem.
Yeah. I guess this is, I mean, you're going to.
But this again is it's again an area where Urbit has this is an area again where Urbit has an advantage, where I think the design is quite elegant because Urbit namespace has value associated with it, right? It's not free. You can't sort of spin up a new identity for free the way you can in Bitcoin or Ethereum. Yeah. And so if you spam people on a network, then you're destroying value for yourself.
Yeah.
There's a cost associated with that.
Yeah. I mean, at the one layer up, yeah, I think it's relatively actually, it's like, I don't know if it's solved, but it's certainly designed correctly. All right, it sounds like Philip can join us.
Good.
Let's see if my OBS config is correct. I don't know exactly how this is going to work. I have you like in a window cropped, right?
I noticed. I like the breach TV. That's really a nice touch.
I'm just reusing some assets that we kind of have lying around. Like I said, I think it's actually almost like something, I feel like doing the streaming thing has kind of taught me something about like pitching or public speaking in general. Like there's one type of public speaking where it's like you really need to have like happy birthday level familiarity. You need to like know it super well, actually totally memorized, like totally rehearsed. And once you like pass a certain level of being rehearsed, you can be genuine.
Right.
And then I think there's another level of public speaking, which is like, just don't think about it at all. And it's actually the in between, where you're kind of like, oh, what am I going to say? Like, how are we going to,
like there's one,
Whoops. Oh.
Wow, Philip totally changed his mind. He saw that I was here. He was like, I don't want to be in a meeting with this guy's in. Hey, Philip.
Yeah.
Hey.
Let me see if I can change. Oh no. Can I turn this off? Oh, cool. I need to make you taller. Now you're basically transported. If you were watching the stream, you've been transported into the future, basically, right?
Right, exactly.
Um, let me see here.
Hey.
Philip, I have like 1,000 technical questions for you, so I hope you've had some caffeine today.
I had some dark chocolate brownies. Yeah.
Sure.
Are they special brownies?
No, just regular Ghirardelli brownie.
That sounds amazing, actually.
I'm also clipped in the stream.
Yeah, no, I know. I'm like trying to fix that.
This looks good to me, what I see in YouTube.
It's getting better. I just have to oops. Oh no. Oh no, it doesn't leak though. I was like worried I'm gonna leak the meeting code. Okay, I think that looks good.
Someone on the stream, the troll box here said that Flag Day seemed to work perfectly. So that's pretty exciting. That's the first time I've heard someone say that they were able to successfully restore their data.
That is exciting.
Yeah.
That's awesome.
Well, anyone on the new post breach network can see that there's at least a dozen of us there.
That's pretty good. I mean, that's like something's working. So are they just back in Urbit community basically?
Yeah, there's a couple other groups that seem to be working as well. When you go through it, you end up with invites to all the groups that you're in before.
Okay.
Although those are for public groups, those are optional. Like you're actually already in those groups. You can just go ahead and it's fine. But it kind of works as a notification that so and so is back online, basically. So I can see a bunch of them are there.
Right. Seems cool. Well, how are you doing? You were up late last night, I think, but like just double checking, I guess.
Yeah, I mean, we were getting the last few changes in until around 1 a.m. or so, and then it was just run one final test net from scratch, migrate Urbit community into it, get everything going.
Yeah.
We realized moons were broken, so fix those, and then I went to bed at like, I don't know, 4 or something, and so it was still up for a while, and Mark was already up,
Right.
The sun never sets on the Galactic Federation.
So let's see. We were talking a little bit about. I feel like there's technical stuff that could be interesting to talk about. Like, yeah, you can give better color on even like, I don't know if my explanation of what a breach, I think my explanation of what a breach is probably like close, but you could potentially make it more technically accurate. And the other thing that'd be kind of funny to talk about is, yeah, like the eras there. I always remember some portion of like 2015 or something where we breached like once a week, which might be funny to, I don't know if you remember that more clearly than I do.
Yeah, there was a while, and I think 2015 was probably the year we breached the most often. And yeah, it was. I mean, there were some stretches where it was twice a week. At that point, it was mostly basically we would go until Zod ran out of memory, and then we'd do it again. Turned out that Zod's memory, well, for many of those, it was just that we had a compiler cache that wasn't very well designed and that was never reclaimed. And so after it compiled a certain amount of stuff, and it was compiling stuff on every event, it would just run out of memory. So
yeah.
This is it. This is it. When I asked when the Galaxy is or when Zod was running, on some old piece of hardware under someone's desk, this is exactly the type of story I was looking for. So thank you.
Yeah, there were plenty of those things. I mean, back then it was, well, first of all, it was a lot easier to breach because it was just restart Zod, restart DOSNet. That's it. No, it's not like 20 ships or something. Um, I mean, and it was, yeah, if like my ship sunk, I would sometimes just like breach everyone because, why not?
Oh yeah, like because
No
you
one should
couldn't
have that power.
uh, generally true for sure. Wait, were we always so? Am I right? Do you remember it as I do that we were always using GCP basically, like sort of like infrastructure nodes are always on GCP.
There was a brief period before GCP. Um, well, there was a brief period it was on DigitalOcean, and then
Oh, that's
I
right. Yeah,
if
a
we
bunch of stuff
were
was on DigitalOcean.
yeah we were on DigitalOcean actually for a little while, and then I don't remember if we went straight from there to GCP. I think we might have. We
I
had
think
a couple
actually
AWS
that's
servers.
it. We didn't get anything for free from DigitalOcean, or we got not that much, and then Google gave us more free stuff. I think, just sort of, we do in fact believe in decentralization, but it's also nice to get free hosting. Um,
Yeah,
uh,
we believe in both free as in speech and free as in beer.
yeah. Uh, let's see. Well, so yeah, so maybe you can do a better job of like. Well, I mean, Lane, you could. I don't know what your technical questions are. I'm actually kind of curious to know if some of my explanations around continuity were correct, but I mean, feel free to like. Um, you want to go first? What are you curious about that I can't answer that Philip probably can?
uh, Talk about continuity first. I need to think about my questions for a moment or two.
Oh, okay, it's fine. Yeah. So, okay, so uh, my so originally it was basically that all of our networking is stateful. So if you have a single ship that runs out of memory or like can no longer keep up its sequence numbers in the networking, you basically have to reset everybody, right? Okay. So I
Right.
just want to make sure I actually like had that correct. And then, okay, so now we have this concept of a personal breach, which is effectively like one ship can say, hey, I've forgotten my sequence numbers, or I've lost my mind. Can you let's reset everything? Aside from resetting sequence numbers, don't you also have to is there some process of like reinitializing subscriptions and stuff like that in the case of like one ship has a personal breach? Because like if I personally breach, and ideally now I should be able to use some form of data migration, how's that work at the like actual user space level?
Right. So formally, a personal breach, like the way that we model it is, um, they were basically declaring that this ship is sunk forever and ever, and you're never going to be able to talk to it again. And so what that means is anything any connection you had with it, you can throw away. You were trying to send it a message, it's never going to get there, so you can just forget about it. You had a subscription to it, you can just close it because it's going to close eventually. You might as well do it now. And so you just kind of apply that to everything. Um, and so if you do a personal breach, normally what happens is you come back and it's as though you're just a totally new ship that happens to use the same name. Um, but there's no other connection. Um, what we have done with this breach and is have a way of basically exporting and importing data. And that's something that we're going to make available for individual breaches as well in the future, although it doesn't quite work right now. But it's pretty close. And so what that does is it says basically, okay, we're not going to try and keep track of any of the low level stuff. We're not going to try and keep track of sequence numbers or even goal subscriptions kind of per se. Um, Certainly not anything in jail, none of the PKI stuff or whatever. Anything that's in any sense derived state, um, we're going to ignore. And we're just going to kind of whitelist a particular set of applications that are going to export their data in a way that they know how to import. And so that, it's just a map of app names to nouns that they know how to import, which is usually just going to be like your chat backlog and the groups that you're in and so on. And then when we boot up the ship, it immediately injects actually an HTTP event because that was just convenient. That gives this to all those apps, and they can do whatever they want with it. And
Wait, does it
usually,
actually come in? Sorry, like that actually seems very curious. So it's like, does this thing just initiate an HTTP authenticated HTTP connection to your ship, like on loopback, and just passes in this giant blob of data?
yeah, I mean, it fakes it, right? It doesn't actually go over any socket. It
Yeah.
creates an HTTP event as though it had come in
Oh,
from.
okay. Yeah, got it.
Yeah, and it just passes that into the Lens app, which then sends it to all the individual apps.
Yep.
And they can do whatever they want. What they generally do is basically reload the state that came in, your backlog, the groups that you're in and whatnot. And then if you hosted a group, for example, it'll send an invite to everyone that
Right.
is in that group, and a couple other small things like that.
Okay.
So
Right. So that's why
this
the
is what
invite's coming.
I remember what I wanted to ask. So Galen, you and I were talking about this before. So if a group of people who are in a group come back online before the group host comes back online, then they won't have the invitations yet until the group host comes back online. I think this is that how the sort of order of things happens here. Okay, so that makes sense now.
Yes,
Yeah, I guess
but
it's tough if
yeah.
you were in a group. So what happens if you were in a group, the host goes offline, doesn't come back online, but you still have an sort of archived version of the backlog, probably because of like the way we do archiving now?
That's correct. You'll still be able to see everything there. It just you won't be able to use it.
Yep. It's true that we like, right, and there's not really any. Okay, wait, so what happens if the group leader or whatever, group host goes down, and then comes back before you come back, but a bunch of other people come back and start updating the state. So when you come online, you get an invite, and then you also like the diff. Your sort of subscription reinitializes, and you do diffs to figure out how to get up to date or whatever.
So you there is the host there?
Sorry, it's like host comes online,
Right.
and then a bunch of subscribers come online. They keep talking or writing or whatever, and then a week later, I come back online. And I still have stale state. I have like, a week ago's state. And then I accept the invite and then start getting new updates. I'm
Yeah.
like waiting for you to be like, just like hang up. Like,
Yeah,
that shouldn't
that's
work though, right?
it'll get the updates while you weren't there. Or at least it should. It's possible that you might not see them immediately. In fact,
Yeah,
it's possible that you might have to wait until your subscription dies for whatever reason and then comes back for them to
yeah,
reload.
yeah,
There's a little bit of wonkiness there, but
yeah,
you'll get all that.
yeah. That makes sense. I mean, just thinking about the way that like subscriptions work, I would imagine like, yeah, when you reinitialize them, you should just get the backlog. Um, well, seems like this went pretty well. I mean, what are you most worried about?
Um, I mean, yeah, I feel really good about it. It took basically 2 hours, 2.5 before I guess we officially announced everything. From when we started taking down ships to when we got it back up. Almost everyone seems to have gotten through. Who's tried it so far, it's gone without any issues. There have been some of mainly people who are out of date for whatever reason, and maybe didn't realize it. In particular, some from long enough ago that our base hashes were incorrect. And so, we're working through those on a case by case basis. But
So actually, that's a good question. What happened, or what would have happened to people who were out of date? Would they just not have been able to run Flag Day or something else?
yeah, you try and run Flag Day, and it would crash for one reason or another, or it would tell you that your base hash.
Gotcha.
It tries to just tell you when you're out of date, but the only way that it can tell if you're out of date is to run a command that may crash if you're sufficiently out of date. So it's all safe for it to crash and everything. So
Right. Interesting. Yeah, I mean, this seems pretty like it's interesting to think about this, being able to execute this in this way. Yeah, like looking at it from the perspective of, 4 years ago or so, because this is a very different experience. It's actually kind of interesting how little we even. Another way to think about it actually is like this is something that we almost definitely need to be able to do, but we have a lot of things we need to do, and it's been hard to prioritize making this possible, like having a breach where people don't lose data. And so it's actually one of the it's kind of like a funny thing to be thrown into, because we're getting a lot of good stuff out of this, but not like I feel like we usually work in a very like feature level way where we're like really focused on, produce a particular, like let people be able to do X or get our reliability to be Y or whatever it might be. And this one, I feel like kind of crept up on us, but then there's all these other effects of it, which are really good. I don't know if that makes sense.
I'd love to hear Philip's take on that. Like, what is this new era? I mean, both in terms of continuity era as well as just like, more generally speaking, like what new functionality is now there, and what does this sort of mean for us, both users as well as developers?
Yeah, I mean, one of the most important, sort of things that this is, it's not even really causing so much as just kind of recognizing, is that, in the past when we did breaches, it was like, it'd be nice if we could like save some data, if we could save some backlog somewhere in a kind of ad hoc way, and we were the only ones who, there was one channel, right? So we would just be in charge of that. And then last year it was like, I noted in my year-end reflection tweet thread that I was like, hey, there's like some data that other people have that it'd be nice to keep around. Too bad we can't,
Right.
but there's like a couple other groups that are reasonably active. And then like this year, so it's been a year since we breached. It was like, no, yeah, obviously we have to keep everyone's data. This data is valuable to people, and we've spent a whole year doing all kinds of upgrades over the air that we never would have tried before. We always would have just been like, we'll just breach. It'd be, rather than writing on the upgrades. And so we've had this mindset shift from, basically from a test net that you can blow away at any time to, no, this is real data, with real people, basically, and it's going to live forever. And there's, you're going to write upgrade scripts. You're going to do whatever you have to do to, move it forward. And, it's not perfect. Every once in a while, a ship will die, and, for whatever reason. But that mindset is such a huge deal. It's something that we've been aiming for a long time. Since 2013, when we first promised that, our last breach will be on October 4th. 2013 was the first time I remember.
One of the Urbit design principles, if I may call it that, is durability, if I'm remembering correctly. And so, I mean, in some sense, that refers to kind of the application itself and things running on it, but it also could refer to the data. And so I also appreciate the fact that the data is there forever, as you said a moment ago, Philip, or hopefully we will get to that point soon.
Yeah.
Like I know that a thing that I put into Urbit, whether I'm sharing it with other people or just storing it in my own Urbit, will always be there.
Right. That's there are technical aspects to making that happen, and then there's also just cultural aspects to that. And
right.
We're finally culturally getting to the point where we're saying, like, yeah, we're going to do that. And for technical reasons, it's relatively easy for us to do. For example, the fact that we can just say, okay, we'll export this as a noun, import it as a noun, is really easy to think about, because just kind of all your data is right there. You don't have to go into a lot of work to be like, okay, how am I going to serialize stuff from this database while swapping everything out? No, it's a noun. It's not even a very big noun. And well, at least as long as we're only.
Yeah, you said it was 20 something megabytes, right?
For my ship, which has has never done a personal breach, so it was up for a year. It was 25 megabytes.
So my peer directory is on the order of 20 gigabytes. I'm just wondering why the difference. There's several orders of magnitude there. Like what else is in that directory if the actual core noun data is so small?
Just all the Bitcoin mining, that Urbit's
doing. We're mining Filecoin now. That's a good question. Part of the answer is basically, we were really wasteful about a lot of stuff, which is something that having longer eras puts a lot of pressure on, because back when your eras last a few weeks, your peers don't get very big, right? And so you just don't care about any of that. But when they last a year, that's when, I mean, Zod is, I had looked, it was like a terabyte. And, um, 998 or 1022 or whatever gigabytes, all but 2 gigabytes of that is an event log, and that event log
That's
is
the answer to my question. I got it.
Yeah.
Yeah.
it like
Yeah.
you can use that to regenerate your state, which your state is never any bigger than 2 gigabytes.
Right.
And so, but like you should be able to just throw away your event log and just keep your state, because that's like their equivalent. You can generate the state from the event log. But we just haven't built. I mean, it's not even hard. Like you can imagine what that code looks like. It's just that there's some
Right.
indexes we have that are like, okay, if we're on event number n, that means I'm going to start from the beginning and go forward n. Well, that's not true. If you can delete those, I mean, it's literally just like finding some indexes, basically.
So we have again precisely the same issue in blockchain, where we want to do this thing called pruning, and our continuity errors are effectively forever, right? Because Bitcoin, there's never going to be a breach in the sense that like all the history goes away. And the way the software tends to be designed, at least in the case of Bitcoin and Ethereum, is that like you have to store all the events, which are the blocks, forever, but you shouldn't have to. So it should be possible to do checkpointing and pruning or something like that. But then of course there's trust considerations.
Yeah, absolutely.
Wait, how are there trust considerations? Like if everyone.
Well, because if you want to, so the way that sort of, let's just talk about Bitcoin. The way Bitcoin is designed is like everyone is supposed to run their own Bitcoin node in theory. You're not supposed to outsource that trust to anyone else. And so if you want to validate anything in Bitcoin, you need to be able to validate everything all the way back to Genesis. That's the only thing you can really kind of trust is the Genesis hash or the Genesis block. And the moment you start doing things like checkpointing, you're now outsourcing that trust to some third party.
Oh, yeah, okay, I already see. It's a hard problem.
If you're the one pruning, it's fine because you already.
Yeah. But you have to trust where you got it.
Right, but if someone
right, exactly.
giving you like later checkpoints, yeah, that's when you're like,
no, Philip is totally right. So the point is like, yeah, if you went through this process yourself and you received all the block data and you verified every state transition, then you can absolutely throw things away. Except that that's not the way it actually works, because other peers will ask you for these blocks and you need to be able to provide them. So it should work that way. And someday it will have to, because Bitcoin can't grow forever.
There's something about these kinds of systems that like still blockchains and Urbit are like in the same family that is not yet defined, basically, is like how I always.
It's a weird cousin from a different dimension, but there's just like so much overlap.
Well, yeah, it's like there's it's just they're conceptually so close, like that you
right.
want this deterministic, you're like, there must be a chain from, sort of whatever from A to B, basically. Like there needs to be a single function.
They're state machines.
Get me, yeah. They're state machines, but then, I mean, almost then also like they're kind of like, there's a design goal there that's shared too, but it's slightly different. It's one of those funny things. It's like, yeah, I'm not really actually the person to speculate about this because I'm too close to it, but it feels like the kind of thing that someone will later figure out why this type of, I think my feeling about it when I like first started to understand Urbit is I was like, actually, the thing that always resonates for me is that it feels much more like a physical thing. It's like a mechanical thing. There's like a state transition is like a physical change in the world, and software.
You can understand and reason about, basically.
Yeah, but it's like you can't roll back from it. Like you can understand why the change happened, but you can't undo it. And that's like such a different world than like MySQL or something like that. When you think about like, I mean, I guess that's not totally true in terms of, it's not completely true, but like, because like database, like single node databases can enforce, single state transitions and be good at it. But Anyway,
Yeah,
I don't know. This is what I'm saying. I'm like, there's something here, but I'm not sure what it is exactly.
if you picture a database, the way that they're often implemented as actually an event log and checkpoint system, then there is a real sense in which they can't go back. That you only add more events to undo it. They of
Append
course
only, right?
prune their event logs. The best actually like language that I've seen for like sort of mathematical language that I've seen for describing this area that's more general than just blockchain or just database or something is in the holochain white paper actually.
That's
Um,
interesting.
they're trying to create tools for building a wide variety of things, including blockchain like things, but also they like you can still within their language you can describe something like Git, which is another one that's kind of related in a lot of ways.
Right.
Um,
Yeah, I think actually a better example of what I was trying to talk about is like the fact that in a, conventional web app, pick your stack, the fact that you can have ephemeral state basically anywhere, like the ephemeral state is a thing, is weird, right? Like that there's not some like if I basically load data out of a database into a node script and I do a bunch of stuff to it, like there's this thing like the I guess I've lived in urban world for so long that the idea of serializing data back to a data store is so totally fucked that it's crazy that anyone ever lived in that world, basically, or obviously most people still do. Um,
So
and
I
that
just wanted
that
to
I think is
mention
a big difference. Anyway, yeah, go ahead.
everything you're saying is totally true. I just wanted to mention that like this, so Urbit is not like the first place I've encountered this design pattern. The first place I saw this was in React web applications and mobile applications, right? So that is precisely the React framework, is that you like make a change somewhere in the state and you kind of can trace it through and follow, the effect it has. And it's like the Redux model, for example, for managing state is actually quite similar at a high level conceptually to what
You
Urbit
just
does.
don't
And
keep an
it is
event log.
clearly a better way of doing
Yeah,
things, right?
yeah. But the difference in those things is that there's no event log. Like there's no way. It's like very. At least last I worked on that stuff, it's like it's really hard to like recreate a past state or to see the chain of transitions. Um, uh,
yeah, I mean,
anyway,
if
I don't know why this is. Yeah,
years basically. I like the experience of developing on Urbit is very much that when you do something it sticks around forever in a way that's in the same way as if you were writing, say, SQL, where you're like, okay, I run an insert thing, and if that command finished, then it's like it happened,
yeah,
and there's nothing more to it, which is very different than writing a normal Unix program in almost any language, anything, C, Python, Haskell, any of those. It's like very much we're going to go into this ephemeral world, and occasionally we're going to save stuff. And we're probably going to mess up when exactly we save it. But as long as you don't kill it in the middle of what it's doing, it's probably fine.
yeah,
And so that, I mean, that's why one of the things I like to say is that, Hoon's only serious competitor is SQL, because it's that kind of mindset.
yeah, yeah. That's interesting. I think that maybe it's like another way, or it's reminding me that I think the demo, or maybe it's even the part, and probably when you can probably dig up one of those 2013. Remember those like Brian Eno soundtrack demos? Helene,
Yeah.
have you seen those? Those are like the first Urbit demos ever.
Oh boy,
Those are
I've
awesome.
already. We're gonna kick off the town hall with a video of one of these demos just to show how far Urbit has come. I haven't
Sure.
seen them yet, but I want to.
Well, like the thing that I think was like I remember seeing that like was one of the first things I saw, and when the process is killed in the middle of a line, he's like typing something in the command line, and then kills the process and restarts the process, and like it's like mid sentence, and the sentence is still
Picks
being
up where it
typed
left off.
exactly where it left
Yeah,
off.
yeah.
And I think I was for me I was almost like Goose. You're like this is the only way. Like how is it that things don't work this way? Obviously, many challenges along the way to realizing it completely. But
Well, so no, this
anyway,
is an interesting question. I think, like, I mean, we're all biased, but we all kind of agree that like this is the right way to do things. So, like, thought experiment: what would it take for most of the applications that most of us use on a day-to-day basis to like work in this fashion, whether it's on Urbit or on something else? Like, what is the main impediment there? Is it
That
bad
is,
software?
we are living that thought experiment right now.
Yeah, software
I think
sucks. I mean, software just
software is
sucks as
so,
a general statement.
oh man, yeah,
You know,
it
there's
definitely
some
does.
really I've got a blog post on this. There's some really brilliant folks who have done a really amazing job of articulating all the various ways in which our like compute stack and application stack just suck worse than most of us realize. I guess people, you know, in fields like blockchain and Urbit probably realize this more than the average user or developer. But this is what brought me to Urbit. So this is like the piece of the puzzle that I find the most interesting.
Well, I mean, the thing that's the most, I always find like, I just like have to punt on because I'm too in the weeds working on this, but I think is an interesting question for someone who's more familiar with almost like the history of technology or history of computing, is that we're unusually far along in the deployment of systems that are, yeah, like, I mean, just that seem fragile. Okay, I mean, forget like what you think or how you feel about them. They do seem very fragile and sort of like loosely,
Yeah.
just, I don't know, that seems risky or something, you know, like that this stuff can't survive forever. But then, and so, yeah, it seems totally possible just given the technical state of all of those systems. Okay, well, these can obviously be improved upon, but the question is much more of like an operational one. I mean, sure, like Urbit is a better computing system. I mean, no matter what you think about Hoon or Knock or whatever, I mean, there's like some pretty obvious benefits. I think, you know, even our most, you know, our loudest skeptics could probably agree on some of the like conceptual framework, right? It's like, yeah, we can all agree that this is the right, you know, that this is the right general outline. But the question is not about that. The question is more about how do you, yeah, kind of go about this, like executing a revolution of that kind. And that is the hard part. I mean, I have thoughts on that too, but I think that's like, it's just a question like, how do you get people to use it? I mean, that's Urbit's only concerned with that basically. Like, how do you actually get people to use it? I mean, I think that's like, and how do you get to use it in a case, it's a different question for early computing, right? So like early PCs, nothing exists, it doesn't exist. Versus now, it's like, well, everyone has a computer. So what is it that and
Well,
nothing like Urbit exists, but it's different.
I think the really short answer to your question, and of course, there's a lot we could unpack here, but the really short answer is you solve problems for people. That's how you get them to use it.
Oh yeah, of course. I mean, absolutely. But it's just I think it's a unique, the thing I always get stuck on is like, I can't find a good historical analog, right? Like where you're sort of upgrading a system that already exists, if that makes sense, right?
No, I think we could probably come up with examples without thinking too hard. I'll give you the one that I usually use. You can tell me if this works for you or not. It's just telephony, right? So we had like the POTS system, like a copper-based. It wasn't packet switched. It was what's the opposite of packet switching? All the connections are like directly routed, right?
Yeah.
And then at some point, something better came along, and packet switching came along, and digital networks came along. And in the very beginning, the internet ran over the old copper wire system. And then this amazing phenomenon happened sometime around the year 2000, you know, sometime in that decade. Usually the word is inversion, right? So we completely flipped. So now the phone network runs over the internet using VoIP. So I think it's not that hard for me to imagine
but
a future where banking is built on Bitcoin.
But the scale is different. I think that's the thing
How
that
so?
is really different. Just the sheer number of, so the internet used to live on top of the phone system, and yes, the phone system had this very different routing, and just the whole technical architecture is like totally different and basically analog as far as I understand it. I'm like too young. Most of the time I feel old, but I'm not old enough to know exactly how that worked. I missed out on freaking phones basically. Yeah, how many people were using, you know, what was the like just total number of users, you know, in the phone system? I mean, it's a lot
Hundreds
of
of millions.
but not billions. You know, I mean, you're looking at a much larger user base.
It's
right?
the same order of magnitude. I think it may have been like, you don't think there were 1 billion people who used a telephone prior to like the year 2000?
Yeah,
I think there probably were.
fair. Okay, sure, it's the same order of magnitude. Yeah, I wonder if it's just like, it just feels like sheer amount of traffic and just like dependence. I guess that's not true. The telephone by the 90s is definitely like a very, you know, it's a pretty much essential part of human life.
Could you imagine? So the Urbit version of this is someday Unix or Linux running on top of Urbit. Could you, like, it again, just a thought experiment. Could you imagine that happening, and what would it take for that to happen?
That's a good question for Phil. Better for Phil than for me, probably.
Have a DOS simulator at some point. I imagine like it. You know, it's certainly not trivial. But I can imagine a couple of different ways of doing it. The best way, of course, would be to get like an EWASM jet and then compile Unix to EWASM if that's possible. But like
you're speaking my language, Philip, and it's going straight to my heart. I'm totally with you on this. I think I know what my next grant application will be.
Yeah, I'm just imagining a deterministic Unix. That'll be something. But yeah, I think in terms of an aspect of the scale that is different is that sort of switching from telephone to internet. I do think it's actually a good comparison in a lot of ways, but it is kind of very much one layer where everything else is either above it or below it and doesn't change all that much usually. Although I mean, I guess some hardware below it does, but and for us, I mean, it's true that we don't do all the layers, right? We're not actually, to get a planet, you don't actually need someone to come out with a truck and a spool of wire. We work on top of IPv4, but we do the higher layers, and those are by their nature more ad hoc, basically. So the lower layers have to be as general purpose as possible, and the higher layers are more ad hoc. And so, I mean, I don't know if it's a scale difference, but it makes certain things more challenging, certain things less challenging, right? The fact that we don't have to do hardware, it makes things a lot easier from a lot of perspectives.
I asked before about the possibility of someday having a knock chip, which I don't know how realistic that is, but I think it'd be cool.
Yeah, I mean, a knock chip in your brain is definitely proper.
This was like one of the most the knock chip was the primary preoccupation of the interns of 2014 or something. What was that?
Wow.
Do you remember that?
So wait, this is a thing that people actually worked on. I didn't know that.
No, not well. I think maybe to the point of like they convinced themselves that it was possible. I mean, I think it's theoretically possible, but
of course it is. Well, I mean, if knock fits on a T-shirt, it definitely could fit on a transistor.
Well, the issue with putting it on, it's hard to reason about because it's like knock is not fast, right? The way that we make knock fast is by jetting it. So then you'd end up with a very system on a chippy thing, I think.
Well, you chip with like a lot of different ports, and you have like your old box of jets that you just plug in, and you don't have a port.
Well, so this question of like an ISA, like an instruction set, I'm not an expert, but I think it's really fascinating. I think a great example here is RISC and RISC-V or RISC-V or however you pronounce it. Like it turns out that like RISC systems, I'm going way out of my depth here, and I'm probably going to sound like a complete idiot, but like they don't work very well in hardware. They're very slow. There's a reason everyone uses x86 and ARM. Actually, I think ARM is like a certain type of RISC. So like I said, I'm out of my depth here. But anyway, there's this chipset called RISC-V that never worked as hardware, but now it's made a comeback as a virtual machine that's being used by certain blockchains and by other stuff. And I think WASM's another example here. So, and then you also have, what are they called? FPGAs, things like that, right? Like I wonder if you could build knock using an FPGA, if anyone's ever tried that, like how that would run.
That was basically what the interns wanted to do, I think.
Right.
Yeah. I mean, I met a guy at an urban meetup that his, I don't know, it was like master's thesis or something, was running the SKI calculus on FPGA. And that's that's for one thing a very low level combinator calculus that's actually quite similar to knock in a lot of ways. That if you squint, knock 2 looks like the S combinator, and knock 1 looks like the K combinator. And so that's like encouraging, and I do think this kind of thing is possible, and you could get significant gains from it. It is also kind of outside of my depth. I've never really been a hardware person.
So Galen, you said knock is slow. I wonder if knock has to be slow. I wonder if it like could be fast if it were implemented in hardware. I don't know.
I mean, it's like saying math is slow. It's like, well, you can do it.
It's actually kind
like
of
the reason the reason, just going back to what we were saying before, the reason that you need jets today is because knock is so different from the hardware. But what if knock were the hardware? Then I feel like the need for jets goes away. Like you don't need to optimize it. It already,
which just needs
you know
to
what
be,
I mean?
yeah, but that hardware still needs to be fast, right? But that's,
Sure,
yeah, I
but
mean,
that's a separate question.
I mean, it really depends on how you
sense.
think about knock. Like, because knock really is a specification language in a lot of senses.
Right.
There's no way that you're going to be able to do hardware that does kind of a, I don't know if literal is quite the right word, but a literal implementation of knock that's going to make addition fast or decrement.
So there's some physics reason, or I guess maybe computer science logic reason why that's the case.
Well, basically, if you do single step knock reductions, then like if your runtime is linear in the number of single step reductions you need,
I see what you're saying. Yeah.
as knock is specified, then yeah, something like addition is going to take at least linear time in the size of your variables, and decrement also will take at least linear time. And so decrement of a billion is going to take a billion times longer than decrement of one, or than increment. And
let's put it this way: it would require a radically different processor architecture. Like it may be possible to, I don't know, yeah, do some type of optimizations in hardware or parallelize or something, but it would just be like a complete reimagining of what a processor was, basically.
Right. And so I think a better way to think about knock is not as a specification for for hardware or how it ought to be evaluated, and more like just this is a specification for what the answer is. And some aspects of that you can do efficiently, kind of in the obvious way, and some of them, yeah, basically you can't. And so those need to be recognized, and I think that we can over time get that down to a fairly small number. I mean, you can trivially prove, or at least convince yourself, that it probably doesn't need to be much bigger than the x86 instruction set. Your jets probably don't need to be any more than that. Although you probably shouldn't be jetting exactly those things.
So x86 is huge and is unwieldy, and like has all this like crazy stuff that goes back to the early 80s. Like I've been studying this recently. It's interesting. Let me rephrase my question slightly. Maybe knock is not the right specification for hardware, but what is? Like, what would the minimal ideal processor, or maybe we could start with like some sort of FPGA to make running Urbit as fast as possible? What would that look like? Again, it's a thought experiment, but it could be a fun project for an intern in the future.
It seems like the first question, or the first answer, is like just get the interpreter to be as fast as possible. You kind of,
yeah.
I always imagined it was like you kind of work backwards, but I don't want to. I mean,
no, but when you say that, you're assuming a few things, right? You're assuming that we have this interpreter, which is written in C, which is running on x86 or some other architecture that we know about today. We're not going to find an answer to this question. It's just a thought experiment. Like if we were to work, like instead of going top down, if we go bottom up instead.
Right.
There's some comments in the YouTube thread as well here. Like Joe said, we'll always need jets and stuff. I just wanted to make sure we're seeing them.
Yeah, I don't know what you would specifically want out of hardware to make it significantly faster. I think Charlie's right that that memory access actually takes a lot of our time, and so you would want to do things like you says, like have large CPU caches, maybe have basically the way that we do that, like, so when like normally you get a lot of speed improvement from memory locality. When you access things, you usually access stuff near it, and the way that we do things right now, we have poor memory locality because nouns are kind of strewn around everywhere, and you can fix some software by maybe somehow identifying, even if it's heuristically, what things probably should be near each other, or you could also in hardware basically rely less on memory locality and maybe more on maybe it can come up with its own concept, heuristically of what things are likely to be near each other. You could have it, if it could understand knock directly, it could do a lot of, right now, in the CPU pipeline, you like it kind of looks ahead at what memory it's probably going to need, and it tries to load that before it even really needs it. And if it understood knock natively, it could do that directly. It's possible that
Exactly.
with a good knock interpreter, even if knock interpreter is written in x86, as long as that's legible to the processor, maybe that's fine as well. But those are the kinds of things that where you can make a lot of improvements. Like it's actually right now, basically, the whole system is slow for all kinds of reasons um, that all kind of multiply together. And so if you just like attach a debugger to your ship, it's very likely doing something that's just kind of really dumb. Um, and like at every level of the system, right? It's something like, yeah, the knock interpreter could be optimized a lot more in software. It could be optimized in hardware if you wanted. The Hoon compiler could be optimized to recognize all kinds of patterns.
Yes. It sounds like the pragmatic answer to my question is that like we don't need to go anywhere near the hardware. There's all these other layers that can and should be optimized first, and I'm totally with you on that.
Yeah, I mean, like for example, we discovered a few months ago, in like July, I think, that uh, on Linux we were spending 95% at least, possibly more like 99% of our time in a read syscall, reading from procfs, because every time that we touched a new 16 kilobyte, I think so big there, block of memory, we would read from procfs to see if we had just Stack Overflowed. And reading from procfs is incredibly slow. And someone reported that, reported years ago that running Urbit was crashing the procfs file system, which is crazy. And we were like, that's weird. Maybe your computer's broken. But it turned out that basically for years and years, um, Urbit was just really slow because of that. And once you fix that, it's like, oh, okay, now it's 20 times faster or whatever. And 20 times faster turns out to be fast enough. And so I haven't really looked at not all that much. And anytime that we do look at something, we see, I mean, there was another case in the other half of the runtime. This was just in the last month or two. Joe found that we were spending, it was something like 95 to 99% of our time printing a date, the current time, printing it to a string that was never ever referenced. And so we just like
Wow.
didn't print it, and it made the all everything way faster.
But Philip, your point is really well taken. Like I think what makes sense to me is that like as the sort of the nature of the things that we're doing with Urbit get more complex and more sophisticated, and as the software we're running on it gets more complex, we will need it to get faster and faster. And it sounds like we will not run out of ways to do that for a long time.
Yeah, basically, there's if you use any kind of reasonable tooling on it, you can see that there's all kinds of ways to speed this up, and that's something that you can kind of know abstractly, and then you can also know by just having done it for over and over, where you're like, it feels like this must be slow, and it's like, yeah, it's probably slow, but it's probably not the slow thing unless you actually check it out.
I feel this kind of like threads us all the way back, actually, because it's like this is the like ethos of developing Urbit, which is basically like it's almost like it's like create problems that you want to have, and then once you have those problems, make the software work. And you're trying not to like. I do think of it like mostly. I mean, from my position, right? It's like it's all about just trying to get the right cadence. It is like walking, basically, right? It's like you never want your steps to be too long. You got to get into like a rhythm of it because the rhythm feels good. But like if you try and go too quickly, you're gonna get exhausted. If you're going too slow, it's not very satisfying. And it's almost all like purpose driven in the sense of like, yeah, either we're like, okay, we really want to do X. Oh, it's really slow, and then we'll figure out why it's slow. And we're like, oh, we really need to be able to upgrade the interpreter, or like, have the OS signal to the interpreter that needs an upgrade. Okay, we're going to have to breach, and we're going to have to get in data migration. We're going to have to get in. It's very difficult. Otherwise, I think, I mean, one of the hardest things about trying to make like a significant kind of like foundational change in any system, you know, software or otherwise, right, is like, I think finding this kind of like mechanism or something. Do you know what I mean? Like basically, how do you like figure out what progress is and how to kind of like manufacture it and keep going? Because one thing to say like, oh, this could be totally different, you know, foundationally different, but it's like, well, yeah, how do you actually, you know, generate that outcome like in practice? And there are all kinds of other things there which have to do with just the pure economics of it, or like, you know, what, yeah, what's it useful for, and so on and so forth. I mean, this, I think in the case of in the context of breach, it's like, yeah, go ahead.
I have a question for you guys. How do you guys, as a team at Tlon, set priorities? How do you decide like what people work on and what problems get addressed first?
Super boring ways, really.
Have you heard of OKR?
Galen waved his magic wand.
Yeah. I mean, it's true. We do run like a very, in the dumbest sense, yeah, we basically just do, you know, what our the patron saint of all Silicon Valley companies, Andy Grove, told us to do, which is to set OKRs and satisfy them. I mean, a lot of that, ideally, that comes as bottom up as possible. You know, it's sort of like, I feel like as we're working on something, it becomes obvious, like either where the opportunities at like the user level are, like what's like new stuff that we can build that people actually want. This is like a good segue. Maybe we should like, Matilda was like, wanted to join at some point, and I was like, how are we going to connect these things? But she's someone who's like working only on interface, right, which has a totally different set of considerations in terms of like you're very much in touch with people. And then on the infrastructure side, yeah, it's like a balance. I feel like, I don't know, Philip, you're kind of the most, it's a balance of both. There's like, there is a kind of idealized, you know, Urbit wants to be this sort of perfect frozen piece of software, and Urbit also wants to be fast enough that people can use it. And so there's like a lot of trade-offs there in terms of like, well, what problems do we solve now? Where do we make things more elegant? And where do we make things more, you know, where do we make trade-offs? And that's kind of like, but I don't know if I'm really, I mean, the really dumb answer is that, yeah, usually it's like, I spend a lot of time talking to everybody, try and get a sense of like where I think we can get to next, try and synthesize that and set like, here's where I think we should go. And then we have a conversation about that. I feel like most of my job is more about driving the conversation and also like setting, just like setting, saying like, let's go this way, you know, like I think we go here, you know, which isn't as, it's not very dictatorial or something. Like it's not, it's, I mean, it'd almost be easier if that was possible, but it's not. I don't know. Does that seem right to you?
Yeah, I think something that we do like that's kind of one of our underappreciated like strengths as a project is basically the way that we're able to use the pressure of being like an actual thing that people use to build the right thing. Because I think that to build something this big, you actually can't just be like, okay, I'm going to ignore whatever, like, you know, actually deploying this and go off in the desert and build the right thing forever.
Yeah.
And so what you have to do is, you know, you kind of have two sources of things that you need to do. One is the stuff that comes up of like, oh, ships are running out of memory, or so and so is losing data, or the network's, you know, kind of flaky or whatever. And then the other is this track of just like, what's the right way to solve these general problems. And that's kind of split into, here's problems that we think we generally know the right direction for, and then, which I call the ORT cloud. And then there's the ones where it's like, okay, actually, you know, the comet has entered the solar system proper, and we can see what needs to happen. And all we need is to, you know, to spend some time on it. And then once you're in, and so there's this interplay basically where if you have a, you know, a relatively urgent problem, then that feeds into what sort of problems should you be thinking of. And it,
This is also kind of a historical artifact, right? Like the interesting thing is it's like when I found Urbit, Urbit was initially basically a PhD project, which is very much a build the right thing type of project. It was just a build the right thing prototype. Urbit did not have a use
Right.
case. And then I think it has this intermediate period and when I found Urbit, it was satisfying this very practical goal that I feel like I had, which was like communication tools shape the way that the world works. And so we need to build better communication tools. But I couldn't have told you exactly what that meant, even at like a sort of product-y, like, interface level. And so there's this kind of intermediate period from probably 2014 to like 2017 or so, where we actually were basically just trying to figure out, like, actually in a way like develop, I think what Philip is talking about, where we had a clearer sense of what do we actually want to build and make this thing do and what is it useful for. And, getting that to kind of harmonize with just like, what is this system and that kind of like just arrived from out of nowhere, and like what is it supposed to be that has very good qualities in certain ways, that we want to.
I want to just what you're describing right now. This is the phase that blockchain is in right now, as a general statement, right? It's like it's a system that has like these nice properties, but we kind of it hasn't found product market fit yet. We kind of don't know exactly like what it's sort of useful for.
Yeah. I definitely feel like we're at that stage of being at the like early product market fit phase, is like where it's like you can see people use it and actually they surprise you in the way that they use it. It tells you something about what it's useful for, which is awesome.
Exactly.
And then you can also see, I actually feel like, especially in the last month or so, it's interesting to me because there's like artifacts of stuff that I was thinking about years ago where I'm like, oh, this is just the fact of control actually is like so materially incredible. Like I used to think that, one of the underlying facts of Urbit, right, is that it's yours. And that you can actually, you can let someone run it for you, you can download it, you can run it yourself, but it's actually yours, right? Nothing can do this. Nothing. There's nothing, not even there is nothing like this. Okay, you can run your own mail server. Good luck. Run your own matrix server, whatever. There's stuff kind of, but there's nothing quite like this. And I always thought that would be something we'd like sneak in, or like people would like use Urbit because of whatever, there was some specific use case people would use it for. But this would be like just, and this would
come
be kind of
come for the application, stay for the philosophy, that kind of thing.
Yeah, something like that. Yeah. But then actually, I feel like what I'm realizing now is that there's things about Landscape that are really useful, but the fact that it's yours is like what is actually just is extremely compelling. And I think we are I feel like, anyway, that's the kind of like just in this process of kind of like, what did we learn from people using this thing, and kind of like, how do we connect that to this as a system? I feel like that's the most recent thing that I feel like I've been learning, where I'm like, oh, this is, and it's actually nicely harmonized, right? It's like you see people really excited about this thing that is a fact of the system. And you want that to be, of course, even more true, like that, it's like, so forward secrecy matters, or portability really matters, or, how we do hosting security really matters, and so on and so forth. I don't know, it's
things that serve that mission. Yeah. I have a concrete, maybe simple question. This is something that Matilda asked in the stream, and I've been wondering as well, maybe for Philip or maybe for you, Galen. So why did you guys decide to go to version 1.0 with this release? Kind of a big milestone.
I didn't decide that, so I'm going to let Philip answer. Actually, I'll be right back.
Right. So the binary was the 0.10.8 was the most recent one we released, which is actually back in July. And we took that to 1.0 basically, well, for a couple of reasons. For one, Semver, like semantic versioning, doesn't make a lot of sense for us. It assumes this model of upgrading or of compatibility that doesn't make sense for us. Our goal is sort of much stronger form of compatibility, but that also includes kind of like upgrading and downgrading protocols that are already out there, which so Semver doesn't really make sense for that, and also Semver isn't really it doesn't work great in practice anyways if anyone tries to rely on the compatibility.
It's designed for libraries, not for protocols, and even then there's issues. I agree. I've had issues.
Right. And so what we need to do then is so basically we're like, okay, we should do just basically two numbers and say, okay, important big upgrades and small ones, more or less. And we're at a point now where we think we can, we believe we can update everything over the air, and so that feels like a 1.0 sort of release, basically, where it's like, we're not, there's nothing about, I mean, it's not that it's done in any real sense, but it's it's done in the sense that people are using it actively, and we intend to support it going forward, and we're not gonna, it's not in a beta in that sense. So I don't know. Yeah, seemed like the right thing to do.
I missed the interim, obviously, but I think before we started this, Lane had noticed this earlier, and we were chatting before we even started the stream, right? And you were like, oh, it looks like it's an actual 1.0. And I was joking that it's like a classic example of us being kind of like a bad software company, because I feel like a good software company would have done like a Microsoft level event, we'd be on stage somewhere, there'd be a giant 1.0 carved out of ice or whatever.
You'd be like, Galen would be like pulling a cloth off something and unveiling something.
Yeah.
We had Urbit OS v1.0 at last breach, I think, right? This is the binary is what we're labeling 1.0, and we also added Kelvin versions to different levels of the system. Hoon is now down to 140, and the others are in the release notes. I actually I need to leave the call for a little while. If that's all right with you guys, need to look at some stuff.
It's fine. I've got to take off pretty soon, actually, too. And I feel like we managed to cover a lot of ground. But yeah, thanks for.
Agreed.
Thanks for coming. I guess we could probably actually congratulations. We made it to the other side. Hopefully, wait, are you I have to go because something is on fire? Or can we in fact be 1.0, we did it. We're on the other side already.
There's something possibly problematic that I need to look at. We'll see.
Okay, all right. Well,
check is okay in the next hour, and you'll know whether something's on.
Seems to me that we did pretty well.
I haven't seen anyone announce anything major blowing up, so I think we can end on a positive note.
Okay, cool. Well,
unless Philip does something we don't know.
We'll see.
And Zod is okay. We'll have updates. Most of the updates will go out through Twitter. It sounds like Discord is also a place to go if you're curious.
Yeah.
But thanks, guys. This is fun. It is an exciting milestone. No ice sculpture, but maybe next time.
Next time.
All right. See you guys.
Thank you. See you.